what am I supposed to do? Just gave a whole rant about what not to do. Hannah, thank you. What did you do first?
I subtracted 3.
Anyone else have a different suggestion first? Yes, dear. Okay, let's do that. Someone help me. I'm going to do subtracting 3 in the next thing, Hannah. So y plus 3 equals what? Okay, and then I'm going to do what Hannah suggested. Subtract 3 from both sides. I'll have y equals what?
Y equals one half x.
Minus 1. 1 half x minus 1. Okay, what form was the original equation given in? Oh my goodness, thank you for knowing that. And what form did we put it in? Okay, if we were to graph the points -3 and -4 with a slope of 1/2, because that's what I'm reading from this point slope form, I would get the exact same line as this. So do we have to do all this work in order to graph? No, we do not. Okay, on the second Mower question, someone remind me, what is the formula for the area of a triangle?
A equals BH. Oh, no. A.
Is it like
No.
1/2?
Yeah. 1/2 BH.
Yeah.
Okay, does everyone agree with that? It sounds very unconfident. Something about a base and a height, and then he said BH divided by 2, or 1/2 BH, and then I heard BH divided by 3, and so what is it for a triangle? One half base. In fact, she sounded so much more confident. Yes, that is the correct thing this whole time, but it was so not confident. Okay, what is the base in this case?
Would be to the 3rd power and e to the 6th.
Okay, Shanti, thank you for all your help. You're out. Okay, what is the height? Okay, and then if I start multiplying everyone except the 1/2, 4 times 3 is 12. Then I have B, is it to the 6th or to the 5th? Is it to the 6th or to the 5th? Why is it to the 5th? Because we add our exponents. So notice that B to the 6th is one of our options because they're checking to see if you know your rules of exponents. So automatically C and B are out. It's B to the 5th and then D to the what? 7, because 2 plus 5 is 7. Hannah, don't answer anything else, please. Okay, so I see this. 12, B to the 5th, D to the 7th. So I go with A, right?
No.
Why not?
It's just 1/2.
It's divided by 2. So it ends up being 12 divided by 2 is 6. 6, B to the 5th, D to the 7th. That is option D. It is D.
For the area, can you just put BH over 2?
You can do BH over 2. It's the same equivalent. I just like to do 1/2 out in the front so I don't have to deal with them until the end. You have to deal with them the whole time. I don't want to see them until the very end. Okay, adding and subtracting radicals. So are there any questions about exponents? You did your I love exponents. Were there any questions on that? Okay, I was hoping if you had one, you'd come see me do a period, but that's what you should do. Okay, for adding and subtracting radicals, are there any questions from the simplifying radicals, the easy one we were doing Friday? Okay, so we're supposed to, we talked about how to do it in prime factored form if we got desperate. That's only if you get desperate. Instead, what you're supposed to do when it's a square root, you're supposed to look for the biggest perfect square that divides into the number. We're going to still need that today. Okay, so it starts off with, you can only combine what?
Exponents.
It normally is like terms. You can only combine like terms. But what we're talking about, we're not doing exponents. We can only combine like, well, radicals. You can only combine like radicals. They have to be like. Well, I don't know what a like radical is, so we need to talk about that. A like radical, like radicals, they have to have some things in common. They have the same blank and the same blank.
Index.
They have the same index, so we can't put a cube root and a square root together. That is true. They have the same index and the same something else. It requires you, yes, it requires you to know your vocab terms on radicals. Okay, so as a general reminder, in case you've not had your Wheaties this morning, if I have cube root of x to the 7th, the x to the 7th all by itself is called the radicand. You know the symbol is called the radical symbol. The whole entire thing is called a radical. And then the tiny number is an index. Make sure your index number is tiny. There are a couple in the room who are writing their index numbers really giant, and it's hard for me to tell a difference. So be very careful. This was all in that handout we used the other day. Okay, so I'm going to actually cheat, and let's look down at the first example so we can figure out what goes in the next box. 2 square roots of 45 minus 2 square roots of 5. What do you think I'm going to put in the giant box now that you've seen the problem?
Wait, no. What's the number called?
I'm not looking for a number. Now that you see the problem, what can we do to that square root of 45?
Divide by 5? No.
Can we break it down? What times what is 45?
7.
Okay, so I know that 15 times 3 is 45. But why do I not want to go with that one? Why do I want to go with 9 times 5?
Because it's
Which one's the perfect square? 9 is the perfect square. If you weren't here on Friday, you need to ask one about their index card. You can use your index card on the test if you would like. Okay, so we're going to come back to that in just a second, but you're on the right track. So the first thing we need to do before we start trying to decide who's like is we need to simplify. We got to simplify everything first. Simplify everything first. Okay, so I'm going to go ahead and go down to that problem that you were trying to help me on. You told me square root of 45 is really 9 times 5. When I give the 9 and the 5 a divorce, what do I end up getting on the next line? When I break down square root of 45. 3 what? 3 square roots of 5. Thank you. Okay, so again, I'm simplifying everything first. I saw square root of 45. I knew I could break it up into the perfect square, 9 times 5. Square root of 9 is 3, so it's 3 square roots of 5. And I'm going to come back. There's still more to do, but I need to fill in the rest of my words. To combine like radicals, it's like combining like terms. To combine like radicals, you need to add the coefficients and keep the same radical. Okay, if you did 5x plus 2x, what would you get? What's 5x plus 2x? 7x. Okay, in the same way, 5 square roots of 3 plus 2 square roots of 3 ends up being 7 square roots of 3. You add the coefficients. You left the x alone. He stayed part of the game, but you didn't say it was 5x squared. You just said it was 5x. In the same way, 5 square roots of 3 plus 2 square roots of 3 is 7 square roots of 3. Okay, so let's go back to our problem. Any questions about this? Let's go back to our problem. I'm still not done because everyone's not been simplified. What's 2 times 3? So I have 6 square roots of 5 minus 2 square roots of 5. What's my final answer? 4 square roots of 5, because 6 minus 2 is 4. So my final answer is 4 square roots of 5. Again, when I saw the problem, I broke down the radical. I knew the square root of 9, that's 3, so it became 3 square roots of 5. 2 times 3 is 6. 6 minus 2 is 4. My final answer is 4 square roots of 5. So when Julia first saw this problem, she probably thought, because Ms. Crumpton said like radicals have the same index. Well, they had the same index. That was both and understood too. But they have the same radicand. She thought, oh, they're not going to go together. 45 and 5 are not the same number. But it turned out after she simplified it, they both ended up having the same number under the radicand. So she could combine them, and that's how we ended up at 4 square roots of 5. Are there any questions about that? Okay, then let's go to the next one. I need help breaking down 12. What times what is 12? 6 times 2 is 12. Why is that not a good option? I need to do 4 and 3 because why? Which one's the perfect square? 4, okay. So what does that become? Okay, but if I give them a divorce and then I simplify, what do I end up getting?
2 square root of 3.
2 square roots of 3. Thank you, dear. Okay, and then if I did negative 3 times 2, what would I get? Negative 6 square roots of 3. So again, I broke down 12 into 4 and 3. I know the square root of 4, that's 2, so I got negative 3, 2 square roots of 3. And then I just multiplied. Negative 3 times 2 is negative 6, so I have negative 6 square roots of 3. Now, is Ms. Compton done? No. Clearly, she's left off these other guys. She's got to go back and simplify with them, too. She was just skipping around because she could. Okay, so I have that 3 square roots of 3. Can I break down the square root of 3, Annie? No, because there's not a perfect square that's going to go into 3. So I'm just going to keep writing it over and over again. But I've got to go back and deal with that square root of 20. Can I break down the square root of 20? What times what?
4.
4 times 5. Okay, and then what do I get on the next line? If you gave them a divorce and simplified, what would you get?
3 times 2 square roots of
2 square roots of 5, perfect. And then, like Maggie said, we'd end up doing times 3, so that's a 5. It's the ugliest 5 ever. It should be 2 square roots of 5. So 3 times 2 square roots of 5. And you do end up getting 6 square roots of 5. So my answer is looking uglier and uglier by the second. Again, I have negative 6 square roots of 3 plus 3 square roots of 3 plus 6 square roots of 5. I don't know why my ugliness went so haywire, but it did. Does everyone understand how I got to here? Am I done?
No.
Why am I not done?
Because you didn't finish it yet.
Okay, who can combine?
Everybody.
Everybody can combine? Does it end up being 3 square roots of 11?
No.
Because 6 plus 6 plus 5 is 11, so why is it not square root of 11?
Because that's not how we work.
Okay, so what am I supposed to do?
You're supposed to combine like terms.
Okay, which ones are the like radicals? The ones with the 3's. You're right, Owen. Okay, so the negative 6 square roots of 3 and the 3 square roots of 3. When I put those together, what do I get?
3.
Positive or negative? Negative 6 plus positive 3, shouldn't that be a negative 3?
3.
So I get negative 3 square roots of 3. And then I'm just going to bring down that 6 square roots of 5. Why can I not combine those two? They're not like radicals. I agree. They have the same blank. What do they have the same?
Index.
They have the same index, but they have different numbers under the radical. And what is that? What is this called, the 3 and the 5? The vocab term that Hiram came up with. The radicand. Thank you. Okay. Well, you like came up with it earlier. No, you did not invent it. That is true. We're not giving you credit for that. Okay. Are there any questions about this? You're going to have a few to work out on your own tomorrow, and there might be 1 or 2 on the test on Wednesday. Really, all this shows me is Jalea, again, all this is doing for me is making it complicated, and that Jalea has simplified square root of 12 and square root of 20 all in one problem. That's all it's doing. It's making my life easier by having one giant problem and her having to simplify a couple things. But you already knew eventually there was going to be a test on simplifying because, my gosh, we've done simplifying for days. Okay, let's talk about multiplying. If you want more practice on either of these, just ask me and I'll find some for you. Multiplying is different than adding and subtracting. Multiplying has always been different than adding and subtracting. Again, 5x plus 2x, you would tell me that's 7x. 5x minus 2x, you would tell me that's 3x. But if I did 5x times 10x, times 2x, good gravy, I'm giving away my own answers. Wouldn't you tell me that's 10x squared? So multiplying was different with x's, and it followed the same pattern. Multiplying is different with radicals. It's not going to be the exact same pattern either. Okay, we can multiply radicals if they have the same index. They do not have to have the same radicand. They only have to have the same index. There are 3 steps. The first step is to multiply numbers on the outside of the radical. Multiply numbers on the outside of the radical. So for instance, I'm looking at that second example. The numbers on the outside are what? 2 and 4. So multiply 2 times 4. What would you get? 8. So far I have 8 for sure. So that's the first step. The second step is multiply numbers under the radical. So I need to multiply 12 times 15. What do you get when you multiply 12 times 15? Yes, 180, thank you. Notice, so I did 2 times 4, I got 8. I did 12 times 15, got 180. Notice that the 12 and the 15 were under the radical, and 180 is also under the radical. You don't suddenly get to jump ship for no reason. If you're trapped under the radical, you remain trapped. Okay, and any guesses on what my third step's going to be?
Simplify.
Yeah, it's going to be simplified. Because I can simplify square root of 180. That breaks down into a perfect square times something. 90 times 2 is a good one. This one is actually a really high perfect square that goes into it. I don't think it's 16. I think it's 36. I'm not sure. You need to try.
Yeah, it's 36.
36 times what?
5.
Okay. So I have an 8 on the outside. And then 180 is really 36 times 5. What does that end up breaking down to? 6 square roots of 5, because the square root of 36 is 6. The square root of 5 we don't know, so it's 6 square roots of 5. Am I done? Why am I not done? I have to multiply. What's 8 times 6?
48.
48 square roots of 5 is my final answer. I did not do 8 times 6 is 48, and 8 times square root of 5 is square root of 40. I do not have 48 square roots of 40. I have 48 square roots of 5. Are there any questions about this? Okay, then someone help me do the first one. It is a bit trickier, although it does look easier.
What'd you do, 2 times 2?
Where's the 2?
Well, I thought it was like an understood 2.
Well, there's an understood 2 for the index, yeah. There was an understood 2 on this index, too.
Oh, then never mind. I don't know.
So it'll be like 4.
No, you're not using that.
You don't use the index. What's understood to be in front of things if they've not written? An understood 1, so really it's 1 times 1, which is 1. So do I even write what I wrote in green? No, so don't write it. But she's right. If we're wanting to be picky, step 1, multiply numbers outside. Technically, a 1 is on the outside. 1 times 1 is 1. Don't write the green. Multiply the numbers underneath. 3 times 3 is 9, so I have square root of 9. What does that reduce to? 3. This is always going to happen. If you have square root of 4 times square root of 4, it's going to end up being 4. Square root of 5 times square root of 5 ends up being 5. Square root of 73 times square root of 73 ends up being 73. Okay, and then we get to the third example. What am I supposed to do on this kind of an example? It's still technically multiplying, but we have a name for it. Distributing. So I'm going to do 3 times square root of 3. And then what am I going to have with the second term? Square root of 18 is what I'm going to have, but not everyone sees that. So let me put square root of 3, square root of 6. 6 times 3 is 18, so I have 3 square roots of 3 plus the square root of 18. Zach saw that in his head to begin with. He does not have to write that first step that I did. Am I done, or can someone be simplified? 18 can be simplified. What can it be simplified to? 9 times 2. So what do you end up getting?
I'm kind of confused right now.
Okay.
So, you said we distribute, right?
Yes, I did 3 times square root of 3 and got 3 square roots of 3. I did square root of 3 times square root of 6 and I got square root of 18. I did 3 times square root of 3, got 3 square roots of 3. Square root of 3 times square root of 6, they're both underneath the house, so I did 3 times 6 and got 18.
I thought that you would, like, keep that under the house.
I did. I kept it under the house. Square root of 18.
About the first?
This one? I did. I kept the 3 under the house. I kept the 6 under the house. This 3 was never under a house. Oh, and I see your hand. You had your hand up. Okay. You had the answer? Please tell me. Yeah. Okay, so if you have this line, the 3 square roots of 3, square root of 18, from distributing, we broke down 18 into 9 times 2, and then we said 9 is really, the square root of 9 is 3, so we have 3 square roots of 3 plus 3 square roots of 2. Am I done?
Can't you combine?
Can I combine? That is the question. Can I combine right now?
Yeah.
What symbol is this? So we're doing addition. What do we just learn with addition? They have to have what?
The same.
And they have to have the same index. They both have the same index, but they don't have the same radicand. They both. This one's a 3, that one's a 2. So this is our final step. We are done. Are there any questions about this one before I blow your mind?
I thought that was supposed to be 9.
Square root of 9 is 3.
I'm talking about, yeah, still at the top.
This, 3 times the square root of 3. You're trying to make that square root of 9. This one's not under the house. That one is under the house. They're not friends yet.
Oh, I thought it was under the house.
No, they're not friends yet. These two are friends because they're both under the house. That's why they multiplied and got 18. You would be correct if it had had square root of 3, square root of 3 plus square root of 6. You would be correct then. It would be square root of 9 plus square root of 18. So that's not what it said because that guy was not under the house. Okay. Zach, I know you've heard this term, but apparently no one else has. This next problem, if you knew how to FOIL, would be a great time to FOIL. If you don't know what FOIL means, then by golly, we're going to distribute, and we're going to distribute twice. So I'm going to try to keep up with the colors. I'm going to distribute the 3 to both of those people. And I'm going to distribute the square root of 3 to both of those people. It's going to be fair. If your mom had ice cream and she had cake, she would make sure your brother, if he wanted it, and you got ice cream and cake. You got both. That's why they're getting both. The purple is the ice cream, the green is the cake. They're getting a little bit of both. We've got to be fair, or else we're going to go cry to mom and dad. Okay, so the purple, I did 3 times 3, I get 9. 3 times negative 4 square roots of 3, I get negative 12 square roots of 3. Again, I did 3 times 3, I got 9. 3 times negative 4 square roots of 3, I got negative 12 square roots of 3. Are there any questions about that? Okay, on the next one, I do 3 times the square root of 3, so I get 3 square roots of 3. I do square root of 3 times negative 4 square roots of 3, so I get negative 4 square roots of 9, because both the 3's are under the house, so I did 3 times 3 and I got 9. Again in the green, I did square root of 3 times 3, I got 3 square roots of 3. That one you're cool with. On the second one, I did square root of 3 times negative 4 square roots of 3. Those 3's are under the house, so I multiplied them together and got negative 4 square roots of 9. Are there any questions about this? Because this is where third period started crying.
What?
No, they didn't actually cry. They just whine. They're whiners. I love them, though. It's like y'all are loud. I don't know. Everyone has their own perks.
So you don't.
We're loud, they whine.
Yes,
I'd rather be loud.
I think so too, but you know,
So
it is what it
you
is.
don't multiply-
Hopefully they won't watch this recording and hear me talking about a math.
So you just multiply what's under the house, right?
Yeah, I did. Those two are under the house, so I got square roots of 9. No, I'm not done. Are you, ask me your question. You're still looking concerned.
I mean,
Yes.
I get it.
Okay, so I'm not done. There are some people that I can combine. Who do you see that I can combine right now?
The 3 and the 3.
Okay, the ones that both have radical 3 is correct. So I've gotten a negative 12 and a positive 3. When I put those together, what do I get?
6.
Positive, what? Negative 12 and a positive 3. When I put those together, what do I get? Negative 9. So on my next line, I'm going to have 9 minus 9 square roots of 3. I brought that 9 down. I did negative 12 plus 3. I got negative 9. And then I'm going to do something on this next step. I'm going to put minus 4, but I'm not going to write square root of 9 again, am I? What is the square root of 9? 3. Are there any questions about this step in purple? I did negative 12 plus 3. I got negative 9. I reduced the square root of 9 to just 3.
This is
This exact one, no. There are no foiling ones.
why would
Sadly enough, you wimps.
Why would he put the radical sign?
What?
I knew the square root of 9 is 3.
Okay.
Like, if I ask my calculator square root of 9, I am going to. So on my next line, I'm going to have 9 minus 9 square roots of 3 minus 12. Because negative 4 times 3 is negative 12.
Oh, wait.
And there's still one more step left.
You gotta put
Which two can go together?
the 9.
The 9 and the negative 12. And what do you get when you put them together?
You get a negative.
Negative 3. So my final answer is negative 3 minus 9 square roots of 3. Now Owen asked what my third period babies asked. Is this going to be on the test? No, there will not be one this complicated. But did we follow it? You didn't ask it like that. They asked it like that.
Wait,
Could we follow it and follow the steps? Of course. Can we persevere and figure it out? Probably. It's still just using all the stuff about radicals. It's still just me seeing that Hannah recognizes square root of 9 is 3. Hannah realizes those two can go together. There's nothing really that complicated. It just takes a few minutes. My gosh, math is going to take a little while. All the good math takes a few minutes.
Where you get the negative 3 from?
9 minus 12 is negative 3. It was a negative 12.